disadvantage in Verilog. Okay. Okay, so can anyone tell me like what are the disadvantages in Verilog? That's why we move to SystemVerilog.
We can in SystemVerilog means we can increase the we can easily means by reducing complexity. There are many keywords. And oops concept also is there in SystemVerilog, so it will be beneficial.
In SystemVerilog, there are objects, there are oops concept, and there are constants and so many things which make the things easy and to code in a very short period lines. Rather than in Verilog, we have to write so many codes, and it's nearly impossible to write so many codes. So we use SystemVerilog to decrease complexity.
Yeah, okay, correct. Okay, so we will see one by one what are the like limitations in Verilog. So we move to SystemVerilog. So first one is in Verilog we have race condition between test bench and duty. So what is this race condition? If you remember in Verilog, both the test bench and duty we were writing inside module. So module means that will get executed in which region? Both will get executed in active region. So my test bench get executed in active, duty also get executed in active. So we don't know in which order they will get executed. Okay, depending on tool, maybe first duty, then TB, or maybe first test bench or duty. So there is no constant order of execution. So that's why we may face like we were facing race condition between test bench and duty in Verilog. So in SystemVerilog, we introduced programming block. Okay, there is one concept program block. So program block, it is made to execute in reactive region. That comes after active region. That means after duty, first duty will get executed as we are writing duty inside the module. Then only test bench will get executed. We are writing test bench in the reactive on the programming block. That is in SystemVerilog. Okay. So we will introduce program block to avoid this race condition. Okay, and another is also clocking block. There is another concept clocking block in SystemVerilog that is used for synchronization purpose as well as avoiding the race condition between test bench and duty. Okay, so now second, some new data types are introduced. Okay, so what are these new data types? So first, why we need new data types? In Verilog, first thing we have 4 value data type. Okay, so it is like 0, 1, X, Z. So in some simulation, we may not need these X and Z conditions. Okay, so if we don't need X and Z, then why to keep X and Z and increase the simulation time? So we can avoid this X and Z. So only with 0 and 1 we can continue with the simulation. So in SystemVerilog, we introduced first 2 value data type that decreases the simulation time. Okay, so here remember my output must be a 4 value data type. Why? Because in output, if due to some reason my output is going to X, I should be able to capture it. So for the output, I should use a 4 value data type to capture the X. But for the input, okay, you just think of a real scenario. If you have designed later adder, to the adder you are going to give the input 0 and 1. We don't have to give the input X and Z. Okay, so that's why in SystemVerilog they introduced some 2 value data type. But for synthesis point of view, 4 value data types are important. So in Verilog, 4 value data type is important, but in SystemVerilog, 2 value data type we can do. For the output, we have to take 4 value data type. But for the input generation, we can take 2 value data type that will decrease the simulation time. Okay. And if you remember in Verilog test bench, okay, we have to use like what we are connecting to DUT input. We were declaring them as range, And whatever the signals we were connecting to duty output, those signals we are connecting as wire. So there is much confusion between raise and wire. Like due to some reason you have made that mistake, then you will get some compilation error or you may not get the proper output. So to avoid the confusion, between raise and wire, they introduce a new data type, that is logic, that can act raise as well as wire. Okay, next coming to arrays. In Verilog, we had only static array. Static array means during the start of the simulation only array size is fixed. In between them, we cannot modify it. So in the SystemVerilog, we have static array as well as dynamic array. And in Verilog also, we like array size or array dimensions that was only limited to 2D, means 2-dimensional. But here we can have multi-dimensional arrays also. Okay. So these are like new data types. Yes.
Associative array is also there.
I'm not able to hear your voice properly.
Associative array is also there in arrays concept.
Associative array.
Yes, ma'am. In SystemVerilog associative.
Yes, we have dynamic array, associative array, queue, but here what I'm saying, just simple static array and dynamic array. That means, okay, so in SystemVerilog, in Verilog, array size was fixed. During simulation, we cannot change the array size. But in SystemVerilog, during simulation, we can change the array size. So it comes dynamic array, it comes queue, there is associative array. That all I'm going to say in the data types. Here I'm just
these queues and associative arrays are comes under dynamic array.
No, not comes under. I'm just explaining you what are the disadvantages we are facing in Verilog, limitations. That's we are
only in Verilog, only
Verilog.
static dynamic arrays.
Yes.
In Verilog, static dynamic array there is no dynamic array. But in SystemVerilog, there is both static and dynamic array.
Dynamic array concepts are there. Okay. There are different types of arrays also, like associative array, as you said. Okay, that I am going to explain you in the data type part. Okay, associative array, queue, but they have their own advantage. But if I compare only point of Verilog, so in Verilog we have only static array. So in SystemVerilog they introduced dynamic array. Okay, again dynamic array has some limitations that is avoided in associative array. Associative array has some limitations that is avoided in queue. Okay. So now this is the data type. Okay. So next coming to 4 is interface. Can anyone tell me what is interface?
Interface is something that for example, you have two dictators and one adder. There are some interface like input, output, and sum and carry. There are some interface connection of wire between our components.
Okay, so interface, I can say it is like collection or group of some wires or signals. Okay, so why interface is introduced? Okay, so in Verilog, we were directly connecting test bench to duty. Okay, through the position instantiation or named instantiation. Directly test bench signal is connected to duty signal. But in SystemVerilog, test bench is connected to duty through interface. So why this interface? In this interface, the advantage is that addition and deletion of signals are easy. Okay, so now you just think, okay, that you have 3 or 4 modules. Okay, so in each module you have decided that okay, three signals will be used in each and every module. Now when your project goes on, you just think, no, I need to add some more signals. So without interface, you have to go to each duty, you have to declare the signals, again you have to come to test bench, you have declared those signals. Okay, so here is every time you want to add some signal or you want to delete some signal, you have to go to module or you have to go to inside your design and you have to change there. But with interface, what will happen? Let that 4 and 5 module have only one interface. Then whatever the signals I need to add, I can directly add in the interface. Whatever the signals I need to delete, I can directly delete from the interface. So I don't have to go to each and every module to add it. Okay. There are other advantages also in interface, but one main advantage is addition and deletion of signals. Now just think this is one module and this is your test bench. Let 3 modules are there. 1, 2, 3. Each 3 modules you are comparing in this one test bench. Okay. So if you want to add some signal, you have to add here, you have to add here, you have to add here, and you have to add here. Okay. So now with interface, what will happen? Now there is this interface. So if you how I connect the signals? Okay. Let some adder M1. So here dot input, then dot input 2, then dot out. Okay, so here these are my module signals and these are my test bench signals. So I have connected like this. Okay, so now if I have to connect them through the interface, then instead of input, I have to write interface name dot input, then interface name dot input 2, then interface name dot output. Okay, so that means I am connecting through the interface. Now let I want to add another signal. So I just have to go to this interface and I have to add the signals here. No need to go to each and every module and add them. So interface means here addition and deletion of signals are easy. So that is, you can say simple collection of signals or collection of wires. Okay. So next. So, yes.
The adder M1, ma'am, the first line, ma'am, adder M1, this is in Verilog, ma'am,
Yeah,
downline
this is in
for
Verilog.
system.
Yes. In Verilog, we are directly giving this like test bench to duty. We are directly connecting. See, you can see simple input are there.
Connection.
So but here we will be connecting through the interface. So any signal I need to change, I just have to change it in the interface.
Okay.
You understood this part?
Yes, coding
Yes,
will be
ma'am.
reduced.
Okay. So now next is there is some modifications in task and functions also that we'll see when we'll go to task and function. Some modification is for loop and some for each loop is added. For loop modification and for each. So once I explain those things, you will understand what are the advantages of those things. Okay. And if you have remember, in Verilog, we have some known as full case and parallel case. That is full case means in the case statements, if you are not mentioning all the combinations, then you have to write the default, else there will be some error. Okay, like some latch will get generated. For parallel case also, okay. So if you are writing with case X or case Z, then a priority kind of circuit will get generated. So those things are avoided here using unique case and priority case. Those all things I will be again explaining when I will go to there. Here just what are the things, okay. And like with the always block. If you remember for combinational circuit, we have to write like always star or we have to write all the input lists here. Then for the latch or for the flip-flop, we have to write passage of clock for the flip-flop. Okay. For the latch, we have to write always at the rate. Here some label like clock. So for different kind of thing, we have to take care of those things. Here, those things are avoided by using always comp block. Okay. Then always flip-flop, always latch. Okay. So next is there.
I mean,
Yes.
now in SystemVerilog also we have also write that pauses clock always has positive.
Yeah, we write. See, SystemVerilog, it is the extension of Verilog. Whatever the things you were using in Verilog, those things you can use in SystemVerilog. So in Verilog, we are using always passage of clocks. In SystemVerilog also we can use. But once I will explain you with the code, then you will understand, okay, what is the advantage of always flip-flop have over these things. And remember, these things are synthesizable also. SystemVerilog, you can use it for the design purpose also. Interface is synthesizable. These things are synthesizable. But if I compare in Verilog, so many things are synthesizable. There are less things that is not synthesizable. So Verilog is mostly used for design. If I come to SystemVerilog, there are less things that are synthesizable. There are more things that are not synthesizable. So we were using mainly for verification purpose, but in SystemVerilog, we can use it for design purpose also. Okay, so there are such things that are synthesizable. Okay, so it's up to you. Once I explain you what is the advantage this always flip-flop have, let you are designing a flip-flop. Okay, so using SystemVerilog language, you can design it using this construct, you can design it using this construct, but this have some advantage over this. With code only, you will understand. All these things with code only, you will be able to understand what is the issue with these things. Okay.
Okay, ma'am.
Okay, so next one is constraint or randomization. Constraint, randomization. This is very important topic. Okay, so first is what is randomization? In Verilog, we have just $1 random function for randomization. Let you have some 10 to 12 variables. You want to randomize them. So in Verilog, we have to randomize them individually. Okay, but in SystemVerilog, we have randomization function. You can randomize individual variables as well as a object. What is this object? I have not said yet, told it. Okay, object means a class concept. Okay, oops concept. So inside one class, you can declare 10 to 12 variables. Then all you have to do is just randomize the object. All the 12 variables will get randomized. Okay, so here randomization in SystemVerilog, it is easy. So next one is constraint. So what is the use of this constraint? Okay. Now let you are just verifying one encoder, binary encoder. 4:2 encoder. Now you just tell me what kind of inputs how you are going to generate the inputs. Hello.
Yes, ma'am.
Yeah. Okay. So binary encoder means the input I need is 1, 2, 4, 8. That means 0001, 0010, 0100, 100. So these inputs I need for the encoder. Okay. So if you are simple writing input equal to $random, then these values may get generated, these values may not get generated. It is a 4:2, then it's okay. But let some like large number of inputs you are taking, 1024 or 2 to the power 10, 2 to the power 20, that kind of inputs. So there, if you are simple writing, okay, let's your input value is 2 to the power 20. 2 to the, it is like 2048. So 2048 to 20. There is a encoder with these things and you are going to check it. Okay, so now if you are going to randomize your input only with $random, then just think how many values you are going to generate. 2 to the power this much. So this will obviously take much time. So instead of generating all random values, I should generate those values I need, because encoder means it is going to operate only with this input. So I need to check my encoder with only these inputs. So how can I generate this input? So this is known as constraint. Constant means you will be generating random values, but those random values will be this kind of random values. So you have to give a constant inside your class that whatever the random values generated, I don't care, but those random values should be like this 1, 2, 4, 8, or you can simply write constant some 2 to the power n. N can be 0, can be 1, can be 2, can be 3. So here your n values will be randomized. So you will get some random values, but that will be like 4, 8, 2, 16 in this manner. So this is known as constant. So without constant, what will happen? I will have a large number of input values that will take much time for the simulation. Okay, understood about constant? Get some idea on constant?
Yes, ma'am.
Yes, ma'am.
Okay, so next one is your, so as I said constant, so here is your coverage. Okay, so once this get disconnected, again you have to connect. Okay. Next one is coverage. So what is this coverage and why I need it? So in coverage, we have two coverage. One is code coverage, another is functional coverage. This code coverage, it will be given by the tool. You just have to understand how this code coverage is generated. So practically what we have to do, code coverage should be or equal to approximately 100%. Functional coverage also 100%. It is not like always 100%. In the specification, whatever the client had given you, if client had mentioned that, okay, if my code coverage is 95%, then also it will be okay. So according to their requirement, you have to check. So this code coverage, it will be generated by the tool. So you just have to understand how this code coverage changes. So if you are not getting 100% code coverage, you have to make some changes in your test bench so that you can get 100%. So there is no issue here. Main part is here. Functional coverage, you have to write your own functional coverage. So you have to properly understand what is functional coverage, because if you are doing some mistake means it is important. Next question is why coverage is important. Just take an example of this encoder. Now I have given you to verify this encoder. You have verified the encoder with some 10 values. And all the outputs are coming correct. But whatever the 10 values you have given, that falls between 0 to 9. Okay, not let 10 values, let some 6 values. So it comes under 0 to 5. So you have verified with 1, 2, 4, but you have not verified with 8. So can you say that your verification is completed? No, whatever the values I need, I have to verify with all the values. So these things we cannot know through the functional coverage. So if my functional coverage 100% means I have verified with all the combinations. So in this case, you will get your functional coverage as 75% because you have verified only 3%. Okay, so functional coverage means how much code or how much specification you have verified. That things you can know from the coverage only. Okay, so these coverage and constant that were not in the Verilog at all. Okay, so understood about coverage.
Yes, ma'am.
So next one
Yes,
is
ma'am.
okay. Next one is in assertions. This assertions also not in the Verilog. Okay. So assertions means it is also used for verification. Okay. So like in the SystemVerilog, we have one block that is known as scoreboard. Okay. In the scoreboard, what we do, we mimic the behavior of the design. It is like reference model. Whatever the reference model I need. So how the verification is done? I have one test bench, I have one design. Okay, one test bench, one design, and one reference logic. Same input I'll be giving to reference logic and I will be giving to my design. Now, if both the outputs are same, I can say that my design is verified. Now, whatever the reference logic, you can write it in separately, or you can write the reference logic inside the scoreboard. Okay, so sometimes what happens, there are some logic that will take much lines of code if I'm writing in scoreboard. So those kind of thing I can write using assertion. Okay, so let's take an example. There is one protocol FTP. In that protocol, we have some like rules that, okay, whenever P select line equal to 1 and P enable equal to 1, at that time, all the like address, data, write rate signal should change. Now, if okay, so P select is equal to 1 and here sorry, this is P enable 0. Okay. So should not change. Okay. Next is there is one wait signal or ready signal. If this ready signal is equal to 1, then our data can change. If ready signal equal to 0, then all signal should constant. Your protocol may be working fine. So, okay. So in that protocol, you are writing into some memory and you are reading something from the memory. So all the writing and reading data you are getting correctly. But if these conditions are not satisfied, can you say that your verification is completed? No. Okay. So remember, in the protocol, whatever the logic you have written for the scoreboard, that writing something into memory, reading something from the memory, that may be working fine. But when it comes to checking these kind of scenarios, then we have to take the help of assertions. In assertion, it will be completed with 1 or 2 line of code. But if I'm going to write some logic for it, definitely it will take much lines of code. So assertions is also used to verify the design. So what is the difference then what we are writing inside the scoreboard? Difference is nothing. Sometimes what happens, the logic may be complicated. With assertion, it becomes easy. Okay. And next that I have forgot to tell initially, that is OOPS concept. That is the main advantage in the SystemVerilog. Okay. So in SystemVerilog, we are using it for the verification purpose. So it need not to be synthesizable. And my OOPS concept, it is not a synthesizable construct. So we can use it for the verification purpose. So OOPS concept means it is total dynamic concept. Okay. So in OOPS, we have so many things like inheritance, polymorphism. So these things are adding some advantage to my verification environment. It will be like, it will make my code reusable. Again, SystemVerilog code is not 100% reusable. If we go to UVM, their code is more usable than SystemVerilog. But its code is definitely reusable than our Verilog code. In Verilog, we have to change everything. But in SystemVerilog, maybe like if I'm moving from one project to another project, we can use the past project skeleton, maybe some changes in driver, monitor, scoreboard, this kind of thing. Okay. So this is all your advantage of SystemVerilog over Verilog. Understood all these things?
Yes.
Okay, so let's disconnect and connect again so that I can start with data types. Okay.
With the same ID.
Same ID. Yeah. Always connect with same ID only.